So now you should have picked up this note sheet from the substitute, okay? Show her that you've completed the first page of notes, and then you can go up and ask her for this worksheet. So this worksheet here, it says univariate data standard deviation notes. We're going to use these questions to help answer and understand more about standard deviations. The first question says snowstorms of note applies to snowfalls over 6 inches. Snowfall amounts for snowfall in Utica, New York are over a 4-year period are as shown. What are the mean and population standard deviation for these data to the nearest hundredth? Hundredth is 2 decimal places. Okay, so we're going to use that same skill that we did before of highlighting or underlining important information. I'm just going to underline it for us right now. So it wants to know the mean and the standard deviation. We are going to rely on our calculator here to help us find the mean and standard deviation. So just like we did before, to find our 5-number summary, we are going to enter the data into the calculator by pressing Stat and Edit. Okay, so we can go ahead and we can press Stat and Edit. It's okay if you have numbers in there, just type over it. Remember when you are typing in to type in very slowly, because if you type in too fast, it will not register what you are typing in. Therefore, you would get incorrect answers, and you would hate for that to happen. Once we have all our data entered in, we're going to press those same buttons to calculate that we did in the last assignment. Okay. Stat, Calc, 1var stats. All these same functions again. So now we're going to hit the Stat button, go over to Calc, select 1var stats, enter, 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 however many times is needed. Now, mean is still this X with the bar on top of it that we went over before. But now we know standard deviation is going to be that little circle with the little tail on it, baby sigma, right here. Okay, so this symbol here, that little circle with the bar on top of it, even if it has the X next to it, that stands for the standard deviation. Okay, so it gives us both in the calculator. So we're going to write our decimal nearest hundredth, so 2 decimal places. So for the mean, 9.4, and now we look at the third number, and that tells us that we should round that up to a 6. So 9.46 for our mean, and then our standard deviation would be 3.74, because I do not need to round because that 3 keeps it the same. Okay, that's all question number 1 was asking us to do, to find the mean and standard deviation. Question 2. In a normal distribution, 68%, so I'm going to underline normal distribution because that tells us we're dealing with the normal distribution curve, 68% is between 72 and 86. The mean is 7. What is the standard deviation? Okay, so what we need to do, anytime you see these words normal distribution, get into the habit of drawing your normal distribution curve. Most of the time you will need to use your normal distribution curve, so go ahead and draw it. Fill in the information that we have. The mean is 79, so we know the mean, that middle number, is 79. 68% fall between 72 and 86. I know that 68%, if we go back to our notes that we had taken before, 68% is 1 standard deviation away from the mean. So 1 standard deviation away, 1 line and 1 line, 68% is between 72 and 86. If I'm trying to find the standard deviation, remember in our example that we talked about here, the difference of 1 box is 1 standard deviation. So I need to find out how much is between either this box or this box. And that'll tell me my standard deviation. So I could do 86 minus the 79, or I could do 79 minus the 72. That's going to give me my standard deviation of 7. So my standard deviation is 7 because it takes 7 to get from 72 to 79. In question number 3, it says, in the accompanied diagram, 68% of the scores fall within the shaded region, which is symmetric about the mean. The distribution is normal, so we know we have a normal distribution. And the scores of the shaded area are between 50 and 80. What is the standard deviation of the scores in this distribution? Okay. So in this case here, the difference between question 2 and 3 is in question 2, we knew what the mean was. Here we do not know what the mean is. So I still need to find the difference, but this time I need to find the difference between both of those boxes. So 80 minus 50 equals 30. So between 50 and 80, there's 30. I know that this is 68%, which is only 1. But 68%, there's 2 boxes. This box here and this box here. So I'm going to take that 30 and divide it by 2 so I know how much changed in this box and how much changed in this box. So 30 divided by 2 is 15. So my standard deviation is 15. Question 4. A set of test scores is distributed normally, normal distribution, mean of 80, standard deviation of 8. Between what 2 scores should 68% of the data lie? So anytime we see normal distribution, we can go ahead and draw our normal distribution curve. It's okay if your lines aren't perfect. We're going to place our mean in the middle. Our mean this time is 80. Our standard deviation is 8, so we're going to put numbers to the left and numbers to the right. I want 68%, and I know 68% is 1 standard deviation to the left and 1 standard deviation to the right. So I do not need to make the full distribution curve because I only need these 2 numbers here and here. So if my standard deviation is 8, I'm going to do 80 minus 8 to get me my number over here, which is 72. And then I'm going to do 80 plus 8 to get my number over here, 88. So then between what 2 scores should it fall? Between 72 and 88. And this is not 72 minus 88. It is from 72 to 88. It's a range of numbers, so leave it like this. Do not subtract those numbers together. On the next side here, it says on a standardized test with a normal distribution, the mean is 20, standard deviation is 2.6. In which interval would the greatest number of scores occur? So normal distribution, mean of 20, standard deviation of 2.6. We want to know where the greatest number of scores would occur. So we're going to draw a normal distribution curve. Put our mean in the middle here, which is 20. And now on this one here, our standard deviation is 2.6, so I'm going to fill in all 3 to the left and all 3 to the right because I don't know what percentage we're talking about or what interval numbers we're talking about. So 20 minus 2.6 is 17.4. Then we'll do 17.4 minus 2.6 and I get 14.8. Minus 2.6 again and I get 12.2. Now on the right we're going to add 20 plus 2.6, 22.6, plus 2.6 is 25.2, and then add it again, 27.8. I want to know where the greatest number of scores would occur. Remember our intervals, we have 68, then we have 95, and then we have 99.7. So out of the 3, the greatest number is 99.7. So between which 2 numbers are 99.7? 12.2 to 27.8. Question 6, the heights of the members of the high school class are normally distributed. The mean height is 65 and the height 72 represents the 84th percentile. What is the standard deviation? So this question's kind of loaded. Okay, a lot of going on here. Normally distributed, mean of 65, and a height of 72 represents the 84th percentile. We want to find the standard deviation. Okay, so what we're going to do, we're going to draw a normal distribution curve. Our mean is 65. Now, I'm going to just write my 3 lines to the left, 3 lines to the right. I cannot fill in these numbers because I do not know what my standard deviation is. That's what the question's asking us to find. What it's giving us, though, is we know the 84th percentile. You probably heard percentiles when they were talking about test scores, okay, and how much, where you score on your test. What percentile? Percentile means how many people did you do better than. So an 84th percentile means that you did better than 84% of the people that took the test. Or out of 100 people, you did better than 84 of them. So what we're going to need here are the numbers on the outside of that normal distribution curve. Remember back to the first video where we made our numbers on the outside of the curve? I'm just going to take those numbers and copy those same numbers over here. 0.15, 2.35, 13.5, 34. If you know one side, you know the same on the other side. It is symmetric. So the numbers that are on the left are the same numbers that are on the right. So now what we're going to do is we're going to add from 0, because this is kind of like 0, this is like 100. We're going to add up all these numbers on the outside until we get to 84th percentile. Okay, so we're going to start with that 0.15, and we're going to add the 2.35. We're not there yet, so let's add that 13.5. Then we'll add the 34. Then we'll add the 34 again, and now we're at 84. So when I added all these numbers together to the second 34, that got me to 84 percentile. So that means right here, this is my 84th percentile. And then the number down here would be 72, because 72 represents the 84th percentile. Now that I have these two numbers, I can figure out what the standard deviation is. The standard deviation is always the difference between two lines. So 75 minus 65 is 7. So my standard deviation is 7. Question 7. The scores of an exam have a normal distribution. The mean of the scores is 48 and the standard deviation is 5. Approximately what percent of the students taking the exam can be expected to score between 43 and 53? So normal distribution, mean is 48, standard deviation is 5. What percent is between 43 and 53? So we have our mean of 48 and our standard deviation of 5. Now we don't know where 43 and 53 are going to lie, so let's go ahead and fill in the 3 numbers to the left and the 3 numbers to the right, and then we can find the 43 and 53. So if we go and subtract our standard deviation, 48 minus 5 is 43. Oh, look, there's that 43. And then if we added it on the right side, oh, look there is our 53. So do I need to fill in the rest of this curve? No. Could you? Absolutely. It's up to you. But I already have my answer here. I need to remember what percent is between the first 2 lines next to the mean? 68%. So what percent? 68%. Question 8. I want you to put a star next to question number 8. You will definitely see this one again, especially on the quiz. 1,000 students took a test resulting in a normal distribution of the scores with a mean of 80 and a standard deviation of 5. Approximately how many students scored between 75 and 85? So here, our important information is that it's 1,000 students, normal distribution, mean of 80, standard deviation of 5, and it wants to know how many students between 75 and 85. So we'll start by drawing our normal distribution curve. Our mean is 80. Our standard deviation is 5, and we want 75 and 85. So if we go one standard deviation away, we can see 75 and 85. So we have to ask ourselves, what percent is between 75 and 85? And that's the same percent that we had up here. One standard deviation from the mean on both sides is 68%. Now our question is not asking us for what percent is between these two numbers. It wants how many students. So how many students specifically? Well, how many students are there altogether taking the test? 1,000. We had 1,000 students, and we want to find 68% of those students. So to find 68%, we're going to multiply by 0.68. So 1,000 times 0.68 is 680. So 680 students. You need that label of students because we're talking about students. Okay. Now you'll be getting the classwork from the teacher, so make sure that you show that you have completed this worksheet, this note sheet, and you'll move on to the classwork, which is very similar to these same questions here, so make sure you're referring back to this worksheet when you're working on the classwork.